As the sun rises over the Guiana Space Center, the team conducts final checks on the health and status of the Ariane 5 rocket and its payload. The James Webb Space Telescope, NASA's #1 science priority. The Webb Telescope is designed to look back to a time when stars and galaxies were first forming, over 13.5 billion years ago. With its revolutionary design and capabilities, the Webb Telescope is about to unleash a new dawn of discovery.
À tous de vidéo, attention pour le décompte final. 10, 9, 8.
Seconds before liftoff, the Ariane 5's liquid-fueled engine comes to full power, followed by the ignition of the 2 solid rockets. We have liftoff. The Webb Telescope is finally on its way, the result of years of study and development by thousands of team members in the United States, Canada, and Europe. Webb spacecraft ascends nearly vertically through the heavy lower atmosphere of Earth. As the rocket reaches maximum acceleration, the spent solid rocket motors are jettisoned safely into the Atlantic Ocean. Reaching the upper atmosphere where protection is no longer needed, the payload fairing is jettisoned and falls away. Accelerating through the atmosphere, the Ariane 5 rocket's first stage expends its fuel and shuts down. The empty first stage then separates from the upper stage. After first stage separation and before second stage ignition, the Webb Telescope has a slightly downward trajectory as it speeds over the Atlantic Ocean. The upper stage motor ignites and the ascent to L2 resumes, never again to be interrupted. The exposed telescope is delicate and must be protected from the sun's fierce heat. To avoid overheating and damage, a carefully designed series of oscillations are performed that provide the necessary protection. Near the end of powered flight, the roll program stops and the launcher then assumes the proper attitude for separation. After separation from the Ariane upper stage, the Webb Telescope continues its journey to L2 under its own power, taking the next step to its final orbital station 1 million miles from Earth. The Webb Telescope is about to unleash a new dawn of discovery. The Webb Telescope separates from the launcher's second stage. The white ring close to the Earth represents the Hubble Space Telescope's orbit, and the larger orbit is the geosynchronous orbit where most telecommunications satellites are located. The solar array is Webb's first deployment. When completed, all of Webb's electrical power needs are satisfied by the solar array for the remainder of the mission. The onboard control system continually monitors and updates the attitude to ensure power generation and thermal safety. To preserve the cleanliness of the mirrors, thrusters are located only on the sunlit side of the observatory. The trajectory is designed without employing a retrofire, which necessitates pointing the delicate telescope at the sun. If course corrections are needed, these velocity additions must be done early in the flight to most efficiently use the mission's limited precious fuel. After completing mid-course corrections, the Webb Telescope passes the orbit of the Moon. Webb's initial transformation is the deployment of the sunshield pallets. The tower separating the telescope and instruments from the spacecraft and sunshield is next. Next, the aft flap deploys. This is key to managing momentum buildup and fuel consumption. This structure helps to balance the pressure from the sun's light on the Webb telescope around its center of mass. After the sunshield pallets reach their final positions, the membrane launch restraints are released. These have kept the sunshield membrane safely in place from final stowage at the Northrop Grumman facility in California through shipment and launch. The sunshield protective covers roll back, permitting membrane deployment. The covers over the core region release next. Then the mid-booms extend and the sunshield assumes its hexagonal tennis court-sized shape. It is now time to tension the sunshield membranes, each thinner than a human hair, pulling each of the uniquely sized and shaped layers to their optimal position. When deployed, the sunshield allows the telescope to cool to 385 degrees Fahrenheit below zero, cold enough to liquefy air, while the layer closest to the sun is almost 190 degrees Fahrenheit above zero, nearly the boiling point of water. It's of almost 600 degrees. Truly fire and ice. Once in the shadow of the deployed sunshield, the telescope and instruments continue cooling down to their final operational cryogenic temperatures. At the completion of membrane tensioning, the secondary mirror deploys into position and is latched rigidly in place. The aft deployable radiator releases and springs into position, allowing the instruments to radiate their waste heat directly into space and away from the telescope. Disposing of excess heat is crucial to the mission so that it does not overwhelm the faint infrared signals to be collected from the cosmos. The cord-fold wings deploy and latch in place, completing the major deployments of the largest telescope in space. As the Webb Telescope continues out to its operational orbit around the Sun-Earth L2, the observatory continues to cool down to its final cryogenic temperature state. A trajectory correction applied 29 days after launch puts the Webb Telescope into its halo orbit, a key part of the mission design. The Sun-Earth L2 point is where Webb's orbit around the Sun is synchronized with Earth's. At this point, 1 million miles from Earth, Webb is free from the thermal influences of the Earth and all eclipses. Additionally, the Sun, Earth, and Moon, the brightest objects in the sky, are hidden by the deployed sunshield, giving Webb a dark, cold, and stable environment to carry out its mission of discovery. Once the mirrors and detectors are sufficiently cold, the wavefront sensing and control operations can begin. This sophisticated multi-step operation's ultimate goal is to position each of the Webb Telescope's movable mirrors into their correct final positions and orientations. Once the mirrors are aligned, the mission team will continue checking out the science instruments, preparing them for operations. Commissioning is completed about 160 days after launch, and the science mission is ready to begin. This brings to fruition the work of the thousands of members of the Webb team from the United States of America, Canada, and Europe. Astronomers from all over the world can now use this facility to study the universe. NASA's James Webb Space Telescope is a game changer which will revolutionize mankind's understanding of the universe. Discoveries made by this observatory will rewrite textbooks, inspiring the next generation of future engineers and scientists. This revolutionary tool will provide mankind with an unprecedented view into the birth of the first stars and galaxies, unleashing a new dawn of discovery.